You see someone with the most beautiful engagement ring you've ever seen. Whoa, that's a big diamond. But have you ever wondered why we use diamonds for our engagement rings? There are 4 classifications of a solid state. Let's dive in and see which one has what it takes to be a diamond. Welcome to our game show. Woo! Let's meet our first contestant, Ionic Solids.
An ionic solid is formed by a cation or positively charged atoms and an anion or negatively charged atom. Each type is surrounded by the other, creating a 3D lattice structure. An example of an ionic solid is table salt. They have high melting and boiling points and are brittle. As we see in this diagram, if there was an impact to our ionic solid, the impact quickly shifts the positive atoms to be next to one another as well as the negatives. This causes repulsion and causes the solid to cleave or break.
Would you want a brittle solid in your expensive engagement ring? Of course not! Our next contestant is molecular solids.
Molecular solids are individual uncharged molecules held together by a force rather than a bond. This force is weak and short range. This is what gives molecular solids a low melting and boiling point. It is very easy to break apart these molecules. Dry ice, for example, is a molecular solid.
Due to molecular solids' low melting and boiling point, we do not use it for our beautiful engagement rings. It's really getting down to the wire, folks. Let's take a look at our next contestant, metallic solids.
Metallic solids are formed by any kind of metallic element, like gold and copper. Atoms in metallic solids are held together with metallic bonds. Each positive center has delocalized electrons floating around the whole solid. Think of it as atoms sharing electrons with the whole solid. These delocalized electrons are what make metallic solids such good conductors of electricity. This property also makes them malleable and ductile, so they can be bent and even pulled into wires without breaking.
A metallic solid is great for being used for bent around the finger in our engagement rings, but do we want that as the big stone? Of course not. So that brings us to covalent network solids. Let's take a look at our last contestant.
All of the atoms are covalently bonded to one another. Covalent bonds are the sharing of an electron between 2 atoms and are relatively strong. All of the atoms are bonded together to make a 3D network. This is what accounts for their strength and hardness.
An example of a covalent network solid is what, you may guess? Yes, a diamond. They have very high melting and boiling points and are extremely strong and durable. And they're beautiful. Who am I kidding? The beauty is the real reason we use diamond engagement rings. They are a girl's best friend.